Good morning, third and fourth graders. This morning I just wanted to review a couple of the science concepts that you guys read in your science books last Thursday and Friday, as well as highlight a few things that you're going to be reading about today. So last Thursday and Friday, you started reading about the sun. And you read that the sun is 93 million miles from the Earth, which is a very far distance from the Earth. You also read that the sun is the closest star to the Earth. Now, the sun looks huge when we look at it, and that is because it is the closest star to the Earth. But it's actually only medium-sized when compared to many of the other stars that are out there in our solar system. And we looked at several of those last week before you guys went home when we were looking at the constellations. Our sun is only medium-sized compared to some of these huge giants that are out there. Then you also read about the size of the sun compared to the size of the Earth. So I have here a globe ball, and if you can imagine with me that we took our Earth and we shrunk it down till it's about the size of this globe ball, which is about the size of a tennis ball. We could fit more than 1 million of these inside the sun if the sun was also shrunk down in comparison to the Earth. So think of a container that has 1 million of these balls in it. That would be approximately the size of the sun in comparison to the size of the Earth if it was shrunk down. Now, this does not mean, though, that the sun is 1 million times heavier than the Earth. And you read that over here. That's because the sun is made entirely of hot, glowing gases, while the Earth is made of solid liquids and gases. Gases are less dense than solids and liquids, so it would only take about 333,000 Earths to equal the weight of the sun. Then you also read about the sun's energy. And the sun's energy comes off the sun with heat and light. So I have here an actual tennis ball, and today that's going to represent our sun. And the energy from the sun is coming out of the sun in all directions, going out in all directions. And if I put our Earth down here as well, remember, are these accurate size comparisons? That's right, no, because there'd be 1 million of these that would fit inside the sun. So our ball that would be the sun would have to be way, way, way bigger, too big to fit on camera here. So we're going to use the two that are about the same size. Just remember that the sun is extremely larger than the Earth. 1 million of these could fit inside of one of these. Now, this energy, this heat and light are coming off the sun. They're going in all directions, and some of that heads towards the Earth. Now, the distance from the sun to the Earth, you guys read, was how far again? That's right, 93 million miles. Now, from here to here on our desk, is that 93 million miles? No, it's not. But if we pretend that it is, it would take the light and the heat about 8 minutes to get from the sun to the Earth. That's how fast our light travels. And your book said that light travels at about 186,000 miles in 1 second. So it only takes it about 8 minutes to get from the sun over here to the Earth. So if for some reason the sun were to disappear, we would still have light for about 8 more minutes before everything would go completely dark. Then you also read about the sun's gravity. And the sun has a much greater gravity because it is much bigger than the Earth. So it's got a stronger pull of gravity. And that pull of gravity is what keeps the planets revolving or orbiting around the sun. And if, they gave some perspective here, if an object weighs 100 pounds on Earth, so think of something that's 100 pounds here on Earth, it would weigh 2,800 pounds on the sun because of the great pull of gravity that's on the sun. Today and tomorrow, you're going to start reading about the moon. The moon is our closest neighbor out there in the solar system. It's closer than any of the other planets. And the moon isn't as far away from the Earth as the sun is. The moon is only about 240,000 miles away from Earth, whereas the sun was 93 million miles away from the Earth. So it's much, much closer. And although when we look at the moon, when we're looking at the moon from Earth, it seems not to be too small. It is actually fairly small in compared to the earth, and this is because it is closer that it doesn't seem as quite as small as in comparison to the sun. But I have here our earth again, and here would be approximately the size of the moon in comparison to the earth. If we'd shrunk the earth and we shrink the moon down, this is approximately the size comparison of the moon to the earth. So you can see that it is definitely smaller than we might think it is. You're also going to read about moonlight. And we can see that when you read about it, you'll see that the moon doesn't actually give off any light like the sun does. The moon reflects sunlight. So the moon is reflecting sunlight from the sun to the earth. If I have my sun out here and I've got my earth out here, the moon is reflecting sunlight. So the sun's rays are going out in all directions. Some of them head straight to earth. Some of them are headed this way towards the moon. And the moon is going to reflect those towards the earth. That's why we think often that the moon is giving off moonlight when it's really not. It's just reflecting the sunlight. The moon orbits the earth, just like the earth orbits the sun. So I want to show you here a few things with this. The earth is revolving around the sun, or we use the word orbiting. So it's going around the sun, it's constantly moving around the sun, and that gives us our year. As it's orbiting, revolving around the sun, it's giving us our year, our different seasons. The earth is also rotating, and this gives us day and night. So while it's going around the sun to give us our year, it's also spinning itself or rotating to give us day and night. Now the moon also does this to the earth. So we've got our moon here. The moon is orbiting or revolving around the earth. And in addition to doing that, it's also rotating. So it's rotating as it moves around the earth. Now it takes it approximately 30 days to go once around the earth. And it also takes it approximately 30 days to do one rotation. The earth moves around the sun. How long? 365 days to make our 1 year. And it rotates once in how much time? 24 hours to give us our day. The moon, it takes it 30 days to go around the earth once, and it also takes it approximately 30 days to spin around like this. So the time for the moon is the same, whereas the earth takes it 365 days to go around the sun once and 24 hours just to spin around once. Because the moon is rotating or revolving around the earth, this makes it change shape. It starts off with new moon, which you are going to read about here eventually, and slowly but surely grows until it reaches full moon stage, and then it shrinks back until we can't see it again at the new moon stage. This is because at certain points it reflects more sunlight. So when it's over here, it's going to reflect more sunlight, then it's going to reflect over here, then it's going to reflect when it's over here. And this causes the moon to change its shape. The final things that you're going to read about in science with today and tomorrow is what the moon is like. So the moon also has high mountains, deep craters, and flat plains, just like the earth does. However, the moon has no air, no water, no plants and animals, because plants and animals need water and air in order to survive. In addition, the moon has extreme temperature changes, which you're going to get to read about. During the day, the temperature is about 216 degrees Fahrenheit, which is hotter than boiling water. And at night, the temperature drops to negative 250 degrees Fahrenheit. This is because the moon has no atmosphere. Remember, the atmosphere on the earth helps to keep our temperature regulated. And we read that back several chapters ago. If you wanted to look back at that, you could. The atmosphere helps to trap in heat at night, so not all the heat escapes. And it also helps to keep too much of the sun's rays coming in to keep us from burning up. God has perfectly designed our earth for us to live on. The final thing that you'll read about that I want to highlight today is the gravity that's on the Earth. The gravity on the Earth and the gravity on the moon. Earth's gravity, we're pretty familiar with it. The moon has less gravity than the Earth does because it is smaller and lighter than the Earth. So if you weigh 60 pounds, or if you find an object that weighs 60 pounds here on Earth, on the moon, it's only going to weigh about 10 pounds. Remember, with the sun's gravity is way greater than the Earth's gravity. And we talked about the difference in there, that if you weighed 100 pounds on Earth, you're going to weigh 2,000, look back at the exact number again for you, 2,800 pounds on the sun. So the gravity is very different from the sun to the Earth, and then it's even greater different from the Earth to the moon. That's all I have for you today for science. Hopefully this little review can help you just kind of remember some of the things and highlight a few of the things that you read last week and then are going to be reading today. Have a fun time remote learning from home.